We are given 4 elements in this question, A, B, C, D, with their electronic configurations. Now we are going to talk about the ionization energies. Okay, for these 4 elements, I will draw the valence electronic configuration in electron inbox diagram. Okay, 3s orbital. Okay, all the valence electrons are in shell number 3. That's why I'm going to show only 3s and 3p electron inbox diagram. Now, element A has 3s2 valence electronic configuration, so 2 electrons in 3s orbital. For element B, okay, 3s2, 3p1. So there's 1 ampere electrons in 3p subshell, and then element C, 2 electrons in 3s orbital, 2 ampere electrons in 3p subshell. Okay, for D will be 3 ampere electrons in 3p subshells. Yeah. Now you can see that their proton numbers are increasing by 1, okay, from A to D. So they are actually 4 successive elements in the periodic table. Okay, they are neighbors of each other in a row. Okay, after first ionization, okay, that means after removing the first valence electrons, okay, let's see what happened to the electrons. So first electrons being removed from element A, okay, from the 3s orbital now, okay, there's only 1 ampere electrons in 3s subshell for A, okay, and 3p, there wasn't any electrons in 3p subshell for A, so of course after first ionization, still no electrons in 3p subshell. For element B, we removed these 3p electrons for first ionization, so there are 2 electrons in 3s subshell, no electrons in 3p subshell. For C, okay, 3s subshell is still complete, okay, and because we remove 1 electron here, so there's still 1 more electron in the 3p subshell. And for D, okay, we are going to remove 1 electron from 3p subshell, so there are 2 more electrons in the 3p subshell. So for second ionization of each of these elements, we are going to remove 3s electron here for A. B also remove 3s electron from this subshell. Second ionization of C will be removing 1 electron from 3p subshell here, and same goes to element D. Second ionization will remove 1 electron from 3p subshell. Now, for a clearer comparison for all the second ionization energy of A, B, C, and D, let's just put them in a graph. Okay, a graph of second ionization energy, okay, versus proton number. A, proton number 12, B, 13, C, 14, D is 15. So remember, this is A, B, C, and D. Now, second ionization of A will be removing electrons from the 3s orbital. So let's say this is the second ionization energy of A. So second ionization energy of B will be higher than A. Okay, why higher? Because although we are still removing electrons from the same subshell, 3s, okay, but B has higher proton number, so higher nuclear charge compared to A. Its valence electron, this electron will be experiencing stronger attraction between nucleus and also electrons for B. It needs more energy to overcome the attraction, therefore higher second ionization energy for B. Now, second ionization of C will be removing this 3p electron. Okay, 3s electrons are experiencing shielding from shell number 1 and shell number 2. Shell number 1 and shell number 2. But removing electrons from a 3p subshell, okay, this 3p subshell has higher shielding because not only from shell number 1 and number 2, also from the 3s orbitals. Remember, 3p subshell is slightly further away from nucleus compared to 3s subshell. That is why, okay, it is easier to remove electrons from 3p subshell compared to 3s subshell. So between B and C, B has higher second ionization energy. So C, okay, the ionization energy will drop from B. Now let's look at element D. Okay, element D, the second ionization is removing electron from 3p subshell also. So similar shielding as element C, also from shell number 1, shell number 2, and 3s subshell. But D has higher proton number, so higher nuclear charge in the nucleus of D compared to C. So D has slightly higher second ionization energy compared to C, but lower than B because electron, okay, is experiencing more shielding compared to 3s electron. So now we can answer the question, which element has second ionization energy higher than each of its neighbor in this periodic table. So B here has this higher second ionization compared to A, C, and D. So our answer to this question is B.